Hello folks, this is Steven from Kenya again. Today we are going to continue with mathematics, and we are going to do a follow-up lesson on what we did last time about natural numbers, place values. If we can do a recap of what we said that if you have a number like say a number like 3, 7, 9, we said that the sum value of this number, the total value can be found, total value of this number can be found using powers of 10, can be found using powers of 10 to determine the value. So for instance here, 9, we start with 10 to the power of 0, which are ones, 10 to the power of 1, which are tens, and 10 to the power of 2, which are hundreds. So if you add up this number, this is the same as 3 times 10 to the power of 2 plus 7 times 10 to the power of 1 times 9 times plus 9 rather, plus 9 times 1, because 10 to the power of 0, any number to the power of 0 is 1. And therefore if you add up that, it will give you exactly what we have, 379. Remember what we said. Again, you can use these rules to find the value. For example, if you have 11, if you have a number, this is base 2, so this is 379 in base 10. We can have something like we can be given a problem like, or we can have a look, a number like this in base 2, 1101 in base 2. If you want to get the value of this, you do the same thing. This time we'll have in powers, 2 in powers of 2. Powers of 2. So we'll have 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, and 2 to the power of 3. And we can see that if you do that, then the value of this number will be something like, in base 10, we can convert this now to base 10, and we will find that it will be something like 1 times 2 to the power of 3, which is 8, plus 1 times 2 to the power of 2, which is 4, plus 2 to the power of 1 times 0, which is 0, plus 2 to the power of 2 to the power of, and then 2 to the power of 0 is 1. Any number to the power of 0 is 1. So we're going to have 1 times 1 plus 1 times 1. So if you add up that, you get that this is 8 plus 4 plus 0 plus 1, which is 13 in base 10. Therefore we can say that 1101 in base 2 is equals to 13 in base 10. Very interesting. 1102. This is just out of our own interest to see that we can apply the place value rules to anything. For instance, and then the thing we need to remember is if you're converting a base 10 number, for example, to base 2, all you need to do is to divide. For example, if you're converting, say you're converting, conversion from one, say for example, from base 10 to base 2, for example. if you are converting, then you'll divide the number in base 10 with 2's and get the remainder. So the procedure is divide in 2's, divide in 2's, and note down the remainder. And note down the remainder. So that's one thing that we can do. So we can say, for example, convert. So the question can be convert 13 in base 10 to base 2. So we use the long division method and we place our 13 there, 13, and we keep on dividing by 2 and noting the remainder. So if we divide here by 2, this is going to be 6 because of 12. Remainder, we have remainder 1. So we note the remainder. That is in the first place value. So we note the remainder. Again, we take what is left here, 6. We are left with 6. So this is 6, remainder 1. So we take the remainder. Then we take again 6. Divide by 2. What do we get? We get 3 because of 6, and we have a 0. Remainder 0. So we have the 0 is the remainder, so we write our remainder there is 0. We are left with 3. Again, we divide 3 by 2. If we divide 3 by 2, here again we get 1 because of 2, remainder 1. So it's 1, remainder 1. We note the 1 there, which is our remainder. And now we are still left with 1. So we take 1, divide by 2. We cannot. So it is going to be 0, 0, remainder 1. So 0, remainder 1, and that is the end of it. Once you have 0 and remainder 1, you are your 1 there. And therefore, we can say that using a series of divisions and noting the remainders until you have 0 remainder something, you have converted your number. Therefore, as a conclusion to that problem, you can say, therefore, 13 in base 10 is equal to 1101 in base 2. Very interesting way of looking at place value of numbers. Let's do something else again. Let's take a practical example. Let's say given two numbers. Given, or rather we can say given a number that has 2 digits. That has 2 digits. A number has got 2 digits. When you reverse the digits, when you reverse the product of the digits, the product of the digits is 72. And when you reverse the digits, when you reverse, that is to make a new number, when you reverse the digits, that is the order. When you reverse the digits, the difference between the original and the new number, the difference between the original and new number, between the original and new number is the difference between the original and the new number is 9. So what is the digit? So the question that comes there is, what is the original number? What is the original number? So how do we go about that? we need to make an equation quickly to solve our problem, and we can say, let the digits be x and y. Therefore, if the digits are x and y, therefore the first equation, equation 1, have a visitor.
Yeah.
Oh, sorry. Let the digits be x and y. If we can say that if we take we can say let the product, then the equation 1, the product in equation 1, the product says that x, y is equals to, if you multiply the two numbers, you get x times y is equals to 72. So x times y will give us 72. Okay? That is equation number 1. Now, equation 2, place value. Place value of first number. First number value